Well, at the end of the last section, we left things in quite a disappointing position. We had started our first pod, which has a web container inside it, and we know that that web container is running on port 80. Now, we quite naively tried to access the cluster using a web browser just to see what would happen, and you saw that really nothing happened. It failed to connect. And I told you at the end of the last section that that's because pods are not visible outside the cluster. And it's by design, because you're going to discover when we go a little further on the course that pods are designed to be very throwaway things. Pods have short lifetimes, pods regularly die, pods are regularly recreated, and as the old saying goes, as I mentioned in the introduction section, we treat pods like cattle. We don't treat them like pets. So because pods have this, as they say, ephemeral life cycle, and that just means short-lived, Kubernetes has a further concept called a service. And the idea is that a service is a long-running object in Kubernetes. A service will have an IP address, and a service will have a stable, fixed port. And what we can do is we can attach services to pods. And I'll show you how that works in a very short while. Now, I have dramatically oversimplified on this caption, so please don't take all of this as if it were technically 100% correct. As we go through this section, I'm going to improve things and I'm going to tighten things up. But this is a very basic, high-level way of thinking about it. With a service, we can connect to the Kubernetes cluster, and the service will find a suitable port to service that request. So we're going to write one of these services in just a few moments, but the next important concept that we haven't met yet is the concept of a pod label. What we can do with a pod is we can set up a series of key value pairs. You can have one or more of these key value pairs. So for example, we might give a pod a label whose name is app and the value is web app. Now this can be anything you like. I've only used this because all of the reference documentation uses as its first example really the key value pair of app followed by some value. We'll play around with that in a short while, and I would like to show you that that can be anything that you as an architect decide you want to use for your pod. That is how we connect services to pods. When we write our service, we provide a so-called selector, and the selector is itself a series of key value pairs. Now, what happens at runtime in the Kubernetes cluster is the service will look for any matching key value pairs amongst the pods, and where it finds a matching key value pair, it will, if you like, connect to that pod. It's not really connecting, but it's going to, well, select that pod. This might look like quite a complex mechanism, and it is, I suppose, but we're going to find in this section that it turns out to be a really powerful and flexible mechanism that we can exploit in many different ways. But for now, this is the kind of basic setup that we're going to need. We're going to need to add a label to our pod, and we're going to build a service with a selector. Enough talk, let's get across to a text editor and write our first service. Well, I recorded the previous section a few days ago now, so of course I've done a Minikube start off camera. Now, if you're starting on a fresh session, the first thing you'll probably want to do is a kubectl get all, just to see what state we're in. And this is quite interesting. Notice for me that the web app pod that we created in the previous chapter is actually running. So you can see that when we start up Minikube again, it's remembering the state that the cluster was in last time. Notice it is saying there has been a restart of that pod. That will have been when I restarted Minikube. Just out of interest, it might be worth doing a kubectl describe on the pod called web app. The job then is to create one of these services for that pod, and that's going to give a networking endpoint for the pod. And again, we can do this in any text editor you like. I'm going to call the file webapp -service.yaml. You call it anything you want. We're back here on the Kubernetes API Overview page that I pointed you to earlier in the course, and we need to find the description of services. And here on the left-hand side is a list of all of the API elements covered by the documentation. We've done pod already. That comes under the general category of workloads. These are all the different ways that we can schedule containers in Kubernetes, and we'll be picking up quite a few along the way. But for services, that's going to come under the topic of discovery and load balancing. Much more on these two topics later on, but service comes under that. So here is Service v1 Core. Again, you can look in the detail if you really want, but the example here is a very good start. Let's zoom in on this. So once again, we're going to have API version :v1. They've got it as the second line here. I don't think it really matters where it goes, but I generally put that at the top. We have a kind service. And once again, we have a metadata block where we define a name for the service. Now, the name of the service is absolutely critical because we are going to be looking up this service when, for example, we have two services talking to each other. Then they're going to use this name. So if you are your project's architect, then it's a very important job to give good, meaningful names to your services and to stick to those names. So we're not going to have any foos or bars here. So we'll think about that when we get there. I'll talk about the ports when we get there. That's going to be a little bit technical. But then we have a section where we define that selector that I was talking about on the caption. So what we're going to be doing is we're going to give the pod a label, which will be a key value pair of app and web app. And the service is going to select for that key value pair by defining app web app as its selector. So that's what we're going to have here, app, and we'll be changing this nginx for web app. Now the type, this is a little bit more complicated, and I'll come back to that once we've got this running. So let's get started. Again, we'll do this longhand, but you can download this as part of the course if you wish. So the API version is v1. The kind is service with a capital S. And the metadata is a block where we have a name. And what we're going to do for this project is every single service is going to begin Fleetman, that's the name of the project, followed by a dash, followed by the general name of the service or the microservice. So much more on that later, but this web application is going to be called web app. So Fleetman web app. And that's it for the metadata block. We then have the spec block. This is the important bit. I'm going to do things in a slightly different order to the example. I'm going to start with that all-important selector. And I think I'm even going to put a comment in here. This defines which pods are going to be, if you like, represented by this service. And really the service becomes a network endpoint for either other services or maybe external users to connect to. So for example, I mean the browser. Okay, so this selector is going to select all pods where the key called app matches the value web app. And now we have the all-important ports section. In this block, we just need to define which ports we're exposing through this service. Of course, this is a web app. We know our container is exposing port 80. So we just need to declare that we are going to accept traffic on port 80 through this service. And we're going to forward that traffic to port 80. That means on the container. This is very much the same as when you're working in Docker and you do a Docker container run and you use the -p argument to publish ports and you do the 80:80 in this case. That's what these two values are here. I think that target port will default to whatever you've specified for the value of ports. Now I like, where possible, just to use the just to add in the information that we absolutely need. I think I'm going to do exactly that. The name, by the way, is just a label. It's just a helpful label to define what type of traffic this is going to be. So that will be HTTP traffic. So again, this is a list, so we'll need the dash, and the name is HTTP, and the port is 80, and as I say, I think the target port is optional, so I'll leave it out for now, and if I get an error there, I can always put it back in later. So that's everything apart from this final entry here, type : load balancer. Now what's going on there? Well, you can probably guess that when we start to deploy this into the cloud, we are going to use things such as load balancers to make all of this work. That's all coming up in the course later. But as stated here in the comment, this is only supported by some cloud providers. So it's a bit of a strange example, this, that they've gone for the most advanced type of service you can have. You'll find if you do try type : load balancer and you try running that locally, at the version of Kubernetes that we're on at the time of recording at least, that will not work. There will be no load balancer available in a local cluster. So we're going to need to specify some different values there, and we have a choice of two types of service. Let's have a look at what they are. I noticed that the type is going to be on the same level as ports and selector, so this is actually part of the specification block. Now, as I said, apart from load balancer, which we can't use locally, you have a choice of two options here. The first option is cluster IP. If you make your service be of type cluster IP, then you're telling Kubernetes that this service will only be accessible from inside the cluster. It will not be accessible to external things such as web browsers. So you're going to use cluster IP if this service is just going to be an internal service, such as our microservices that we're building. Many of the microservices that we're building, we will not want to expose to external traffic. We just want other microservices inside the cluster to talk to it. In that case, cluster IP would be the right choice. It makes it a kind of a private service. That's just my terminology, but that's the way I think of it. It will give this service an IP address, and that IP address will be stable because services are long-lived entities in Kubernetes. Remember, pods come and go. Pods will constantly die, pods are going to be restarted, and that's the point of having this service, to act as a front to the pods so that we can have stable IP addresses. So actually, cluster IP is probably going to be what we use for most of our services when we start introducing the microservices, but of course that's not the right choice for the web app. We want the web app, of course, to be exposed to the outside world. So for that reason, the type we're going to need is the final choice available, and that type is called a node port. This is where we are going to expose a port through the node. The node in our case is the entire Kubernetes cluster. Of course, when we go further with this, we are going to have multiple nodes in a cluster. But this means we're going to expose a port through the node. Now, the deal with a node port is that we, as the architects, can choose what port we're going to be exposing to the outside world. Now, when we have a service of this type node port, what we're allowed to do in the ports block, and this is only for node ports, we are allowed to specify what the node port is going to be. So we can choose a port number here, and that's going to be the port number that the web app will be accessible through the browser. So you might be thinking, great, let's put in 80 here, but that's not how node ports work. The deal with node ports is Kubernetes will allow you to use any port number greater than 30,000. So it's actually going to be something like, and I'm going to go for 30,080. 30080. Now, I think most people, when they first come to Kubernetes, find that quite a strange restriction. Now, you can, when you start up Kubernetes, for us by starting Minikube, you can override that restriction. You can tell it to use a wider range of port numbers. The apparent reasoning for that restriction is just that we want to avoid the possibility of having any clashes of ports. Now, unless we specify otherwise, all of these port numbers are automatically generated by Kubernetes, and therefore Kubernetes can make sure that there are no clashes of port numbers. Of course, we can't reuse ports. Now, with a node port, for the first time, we as architects are selecting a particular port. And the Kubernetes designers are nervous that we might end up clashing with some of the ports that are being used internally by Kubernetes. So it's a bit of an odd one, that one, and I will let you research that if you're interested. But I can promise you that this proves to be no real problem at all. You can think of this node port as being a temporary development feature where we're going to, just for the purposes of running locally, we're going to use this fairly clunky sounding port 30,080. But as soon as we go into production, when we move on to a real cloud environment, then we're going to be replacing this node port with a very featureful load balancer. And that load balancer will be easily able to expose a sensible port like port 80. If you really are in the situation where you're not going to be deploying in the cloud and you absolutely must use port 80, then it's quite common to use something called an ingress service. And I'll show you how ingress services work a little bit later in the course. But for now, I just want you to think of this node port as being a slight development restriction that will go away once we move into production. Well, unless I have any typing mistakes, I think that's it. With this definition, we are saying we are going to have a service called Fleetman Web App, and it's going to become a network endpoint for any pod it finds in the cluster with the key value pair app and web app. It's going to be talking to the port inside the pod, which is 80, but it's going to expose to the outside world pod 30,080. So that's done. We're going to switch to the terminal and apply this to our cluster. Now, there is one last job that we haven't done. I wonder if you've spotted what I've missed. Well, I'll let you think about that, but in the meantime, we can try to deploy this service to the cluster. And for everything we do in Kubernetes, it's going to be the same syntax, kubectl apply, followed by -f, followed by the name of the file that we're applying. So it's exactly the same syntax we used when we were deploying the pod. Let's see if that works. Well, apparently it says Fleetman Web App created. And we can do a kubectl get all. And we can see here that we have the service Fleetman Web App. It's of type node port. The cluster IP is just the internal IP address inside the cluster. That's not relevant. The external IP, people tend to panic here when they see a none. Just ignore that. You really don't need to worry about that. You will only see something useful there if you're using a load balancer. But what's important here is this is saying that externally we're exposing port 30,080. It's kind of the opposite way around to how you might have expected it if you're used to using Docker. I do find that a little bit confusing, but the important port is 30,080. Now, as I said, I have sort of deliberately missed one crucial step. So I don't think this is going to be working right now. Minikube IP, that's the IP address we need to visit. So let's try that, and that will be :30080. And yes, site can't be reached. It tried to connect though. It did take quite a long time before I saw that error. So clearly I've missed something. The way that services work is via this selector. By specifying in the selector block app:"web app, we're saying that we want Kubernetes to find any pod in the cluster that has that key value pair as part of its set of labels. So we need a corresponding label of app:"web app in the pod. Now this is our service description, but what we didn't do in the previous video is review our pod declaration. So very simple pod declaration. The name of the pod is web app, but of course we never gave this any labels. Now we provide the labels in the metadata block, so this will go at the same level as the name. And for labels, I know I've mentioned this several times, but the labels can be any key value pairs that you choose. So we've been going for app:web app, but I really want to be clear that this is completely arbitrary. To demonstrate that, I'm going to change app to be my label name. Not a very good label name, but I hope that illustrates the point that we can choose anything. As long as they match, of course. So here, back in the service now, I would need to make sure that the selector is looking for any pods where my label name matches the value web app. So we'll try this out, and once we've tried it, I'll switch the label name back to being app. So I've changed the service and I've changed the pod. So for that reason, I will need to apply those changes. And to apply a change, wonderfully, it's exactly the same syntax. We just need to do kubectl apply -f. And you know, it really doesn't matter which order we do this either. We've got two files to apply. We've got the webapp-service.yaml file. And rather than saying created, it said created last time, it's now saying the service has been configured. And we can do exactly the same thing by doing an apply on the first pod.yaml file, and now that pod has been configured. So I'm hoping now that the service will have selected the correct pod. So we should now, if I go back to the browser where I had the failure before in the last video, it was the Minikube IP address :30080. Let's do a refresh. And I hope that's working for you as well. This is the very basic release 0 prototype of the vehicle tracking system. There's no vehicles on here, but there is a map. Clearly we've got a lot of work to do on this application through the course, but it is running. So I hope I've proved then that this label is completely arbitrary. You'll find throughout the Kubernetes examples they use the label of app:, and I just get the feeling that people think it has to be called that, and it really doesn't. But I guess for consistency it's worth us using the same label name. So I've changed the pod, and in the service then it's the selector that we're looking at here. We'll change that back to app as well. Can I mention that in the metadata, the name, that's not arbitrary. That name does have to be name. Every entity in Kubernetes has a name as part of its metadata. But the labels, anything you want. So I guess because I've made that change, I should do an apply. So I'll apply the change to the pod, and then recall the command to apply the changes to the service. And then back in the browser, I'll do a refresh. And yes, the page is still rendering. Now, we have been told by the developer that a new version is available, release 0-5. It's still a prototype, but apparently they've made the page look a bit nicer. They've put a menu bar and some kind of other stuff on the page. And it's our job in this video to deploy the new version. Now, we could do that quite easily. We could go into our pod definition here, and we could change this pod definition. And don't follow along here because I'm not recommending this. We could change the release to 0-5, and then we could do a kubectl apply, and we could effectively change the pod. Problem with that is, remember, the pod is really just a wrapper for a container. Now what Kubernetes would have to do is stop this pod. It's going to have to start a new pod. It's going to have to pull the new container image, and it's going to have to start that pod up. In other words, we are going to have some downtime. We're going to be talking a lot in later chapters about how to deploy with zero downtime. And there are some built-in, very elegant mechanisms in Kubernetes available to do that. But until we get there, we can do a simple deployment with zero downtime using these labels. I'm planning to add an additional label. And maybe I've not made that clear. You can have as many labels as you like for a pod, and you can use as many of those labels as you wish when you're doing the selection. So we're going to add an additional label, and this is going to be a release label. Remember, these labels are arbitrary. So we'll label our pod release:0. Now we can add that then into the selection rules. And the way this works is it's an AND. So this service is going to select any pod which has a label of app, web app, and a label of release 0. So once we've added that label, we're going to end up with exactly the situation we had before, where this service is exposing a port to the outside world, and it's forwarding the traffic to our pod. We need to deploy a new version of this web app. So the plan is I'm going to create a second pod which is going to contain that new release. Now I'm exaggerating here, but I'm trying to illustrate that that pod is going to start up quite slowly. It has to pull the image and the pod has to be started. So that took quite a while. But of course it doesn't matter because the website is currently, if you like, connected to the old pod. And now the magic of this is that we can, at our leisure, simply go to the service and change the selector. We can change the selector now to be release 0-5, and so now the service will direct traffic to the new pod. And the difference is that will be a very fast operation. It's not like waiting for this pod to start up. And it means, of course, we can switch between these at will. So how you use these labels is really entirely up to you, but you can start thinking now about how you could maybe use this to support a production and development release in the same cluster. Now, I'm going to be showing you how to do proper rolling deployments later on in the course, which is a more elegant system than this, but it's a really good demonstration of why we have these labels and selectors. So let's give this a try. So we're going to need a new pod definition. Now you could do that in a separate file, no problem with that at all, but it's very common to combine multiple definitions into the same document. And we can do that by using the document separator in YAML, which is 3 dashes. So after the 3 dashes, we can now go ahead and define our second pod. Well, I'm going to do that just by copying and pasting. Copy the first pod. There's our second pod. Now the name for this, as I said, the names don't really matter of pods, but I'll call this web app-release 0-5. Could be any name that you want really. And the really important thing is we'll need to change the image. The image is going to be release 0-5, so make sure you make this change here. And of course we need to set up those new labels. So for the first version, the label I chose was release, and the value is going to be 0. And for our second pod, the label will be the same release, but this time 0-5. So that's the pod definition. And now for the service. Just to start with, we'll change the selector so that the release is selecting on release 0. And that's all the changes we need to make. So when we apply this, we should end up in this position where everything is the same as before, except we've got this additional label, and we will have a new pod deploying, and that might take a while to start up. But no problem, the old pod will still be in service. Let's try that then, and I can do that by recalling commands. So I'm going to, first of all, apply the pod definition. Oh, and I always forget this, and I'm glad it's happened so I can demonstrate it. It looks like a scary error, cannot convert int64 to a string. You can probably guess that in YAML, this 0 is being interpreted as an integer. It needs to be a string. We just need quotation marks around that label. And of course, we'll need to do exactly the same with the pod here, and I guess here as well. Not sure about that one, but let's do it anyway. It can't hurt. So with that fix in place, let's try applying the pod definition. Oh, and it's saying that release 0-5 is unchanged, and that's because I hadn't spotted this. It did accept that 0-5 as being a string, so it did create that pod in the previous step. And we also need to do an apply for the web app service. Make sure you've applied both these files. That one looks okay. And we can review everything with a kubectl get all. So we now have two pods, the web app and the new web app. And we have the service. Now, just looking at this, we can't see what the service is connected to. So I guess we could do a kubectl describe. Now, I don't think we've described a service so far. With the describe command, we always have to say, what are we wanting to describe? We can't just say describe fleetman-web app. We will get an error there. It doesn't have a resource type, Fleetman web app. It's actually looking for, are we describing a service, a pod, or something more complicated? So we have to plug into here, describe service. You will find that many of the Kubernetes commands are quite long, and you can do some shortening. It is very common to shorten service to SVC. I'll probably be doing that quite a lot on the course. So let's look at the output on that. And the important one is we can see here the selector is selecting on app web app and release 0. Well, is it working? Let's do a refresh on the browser. We should get back, and we do, the same page we had before. Hope that's working for you. But now for the exciting bit. We can now go back into the service and simply change the selector to 0-5. Then back on the console, all we have to do is recall the kubectl apply -f web app service. We're not changing the pods, it's just a little bit of a rewiring of the service, and it will be almost instantaneous. I'm going to go really quickly here. As soon as I hit enter, I'm going to switch to the browser and do a refresh. Let's try it. Now, I've noticed that because I think the browser is able to cache this application, if you just do a regular refresh, you may well keep seeing the same page as before. You will possibly need to do a hard refresh, so depends on your browser, but usually a Control and F5 or just Control and click on the refresh icon should bring you back to the new release of the app. So it looks slightly better. So I hope I've given you a good feeling there for the power of these labels. Just a couple more commands before we wrap up this section. We have seen that you can do a kubectl get all, and that's showing us the pods and the services. But if we're interested in just getting the pods, then we can always do kubectl get pods. And that can be shortened further to get PO. You'll see a lot of Kubernetes engineers doing that, so I would get into the habit yourself. Now, it's a shame that we can't see the labels on this list because that would be very useful for debugging. But you can. You do have to add in the --show -labels option, and that will show the labels applied to each pod. That's very useful. And perhaps even more useful still is we can do a get, is we can add in an extra command -l, and that allows you to apply a selector. So we could, for example, apply a selector where the label release is equal to 0. We'll filter down the list of pods, in this case just to the release 0 pod. Or of course we could do the same for the 0-5 pod, and there it is. Of course, if we use a label that doesn't exist, so we go for something like release 1, then we're going to see no resources found. So when you're setting up those selectors on the services, that could be a really useful debugging technique. Much more to come on rolling deployments later on in the course, but for now I hope you've got a good feel for services and you've got a good feel for how we can use labels to determine which pods a service is connected to.